Hello friends, welcome to NEET Physics. So today we are going to do the next part of solution, that is NEET Physics previous year solutions from units and measurement. As you know that we have already done our part 1, so you can visit and watch that from here, and link is also in description, so you can also watch from there. As we have already done till question number 9, I'll start with question number 10. Mostly there will be the questions based on dimensional analysis. So let's start with them. Our question is Planck's constant, small h, speed of light in vacuum, small c, and Newton's gravitational constant, capital G, are the three fundamental constants. Then which of the following combination of these has the dimensions of length? So we have four options. The option A is root of hg upon c raised to 3 by 2. The option B is root of hg upon c raised to 5 by 2, and option number C is root of hc upon g, the whole thing under the root, and option D is gc upon h raised to 3 by 2, the whole thing under the root. So let's start with the solution. The unit of length is meter. We already know that the unit of length is meter, right? And now using this you can write dimensions of length as L1, M0 and T0, because here only length will come, okay? So L1 and other things will be 0. The units of Planck's constant, that is small h, is joule second. You already know that because it will be given as your constant values in your question papers. So you can take it from there, okay? You don't have to by heart it. And now you know that work done is force into displacement, and for force you can write mass into acceleration, and for displacement this is x. You already know that mass can be written as kilogram, okay? So this, the unit of mass can be written as kilogram, and the unit of acceleration can be written as meter per second square, and the remaining displacement will be having the unit of meter. So now combining them all, you will get kilogram meter square per second square, which is nothing but the alternative unit for joule, that is joule in terms of fundamental unit. So now we can write our joule second as kilogram meter square per second square and multiplied by second, okay? And this will give you kilogram meter square per second as unit of joule second, okay? And from there dimensions of Planck's constant can be written as L2, M1 and T minus 1. As you know, because this is length, so from here meter square length will become 2, from kilogram mass will become 1, and from second in denominator you will get T raised to minus 1. So L2 M1 T minus 1 as the dimensional formula or dimensions of Planck's constant. Now the unit of speed of light we already know, that is 3 into 10 raised to 8 meter per second, and it is velocity, right? So unit will be meter per second. And from there you can write the dimensions of speed of light in vacuum as L1, M0 and T minus 1. Again it is very simple, meter for length and second for time. So this will become L1 and T minus 1, M will be 0. The unit of Newton's gravitational constant, that is capital G, is Newton meter square per kilogram square. You will get this as given value, that is the value of universal gravitational constant. So this will be given to you in your given data, and you can take it from there, okay? Or you can by heart it as well. So you already know that this Newton meter square per kilogram square can be written as this, because Newton is what? Kilogram meter per second square. This is your meter square, and as usual kilogram square will come here, okay? And combining them all will give you this, okay? Combining them all will give you this. So you can write this, that is your this term as this, in the terms of fundamental unit. So now the dimensions of gravitational constant G can be written as L3 m minus 1 and T minus 2. Again it is very simple. Meter cube will give you L3, kilogram will give you m minus 1 and second square will give you T minus 2 because these both are in denominator, therefore you can see this negative sign. So now we have dimensions of length as L1 m0 t0, dimensions of Planck's constant is L2 m1 t minus 1, dimensions of speed of light in vacuum as L1 m0 t minus 1, and finally dimensions of Newton's gravitation constant capital G as L3 m minus 1 and t minus 2. Now let us suppose L is equals to h raised to x, c raised to y and g raised to z. Okay, so because we have to write them in terms of L, right? That is in terms of meter, the dimensions in terms of meter. So going ahead and substituting dimensions of them, the given values that is h, c and g and L will give you this. Okay, and I am taking this as star. Okay, equation number star, always remember. So now on solving this further you'll get this. Okay, as you can see 2x 1x minus 1x. Okay, now on solving again it further you'll get this as L raised to 2x plus y plus 3z, m raised to x minus z and t raised to minus x minus y minus 2z. Okay, you have done nothing. Okay, as you have multiplied these things the powers will get added, right? And then you will get this. Similarly for m, similarly for t, as you have got for L. Okay, and now combining L with L, you can compare the powers. This is 1 and this is 2x plus y plus 3z. So comparing their powers, and that is comparing both the sides. So comparing both the sides of the given equation or expression, you will get the first thing as 2x plus y plus 3z equals to 1 from L, x minus z equals to 0 from comparing m, and minus x minus y minus 2z as 0 from t. I am giving it as equation number 1, giving this as equation number 2 and giving this as equation number 3. Now I'm going ahead and adding equation 1 and 3, that is 1 plus 3 will give you, this is your equation 1 and this is your equation 3, right? So now adding them both, you'll get x plus z as 1, okay? And I'm giving this as equation number 4. Now after this, we know that x minus z is 0, right? From 2. So now adding 2 and 4 as well, that is x minus z equal to 0 and x plus z equals to 1. So this is our equation number 2 and this is our equation number 4. And now adding them will give you 2x equals to 1 because you know this z will be cancelled, right? And you'll get this as 2x is equals to 1. And now changing the sides and rearranging will give you x as half. And I am giving it as equation number 5. So now you already know that x minus z is 0, right? That is, you can write x is equal to z and you know that x is half, right? From there, you can write x is equal to z equals to half because you already know that from equation 5 x is half and x is equals to z, right? From 2. So from here you got the value of x and z. And now I'm giving this as equation number 6 and substituting these values, that is x equal to z equals to half, in equation 1 or 3. So I have substituted this in equation number 3 because it is quite easy. So substituting this, you can write half on the place of x and half on the place of z. Then you'll get this as minus half minus y minus 1 because you know this will get cancelled. That is, you are just dividing, okay? And then you'll get the value of y, okay? So this is our equation number 7 and final equation. and using these equations, that is equation number 6 and equation number 7. So from equation 6 and 7 you can write x equal to z equals to half and y equals to minus 3 by 2. And now substituting this in equation number star, which we took initially, that is this equation. So we'll get L as h raised to half c raised to 3 by 2, which is with negative sign, okay, and g raised to half, okay. So now this minus 3 by 2 will go into the denominator and will give you plus 3 by 2, and you already know that this half and half will become roots. So h will come under the root and g will also come under the root. So from here you can write L as root of h into root of g divided by c raised to 3 by 2, and now combining them will give you root of hg upon c raised to 3 by 2. So from there you can already notice that our right option is option A. So this is our final answer. Let us do one more numerical based on dimensional analysis so that you can solve the remaining problems or some practice problems. If the dimensions of critical velocity, that is Vc, of a liquid flowing through a tube are expressed as eta raised to x, rho raised to y, and r raised to z, where eta, rho, and r are the coefficient of viscosity of liquid, density of liquid, and radius of the tube respectively. Then the value of x, y, and z are given by, we have given 4 options, which is minus 1, minus 1, minus 1, 1, 1, 1, 1, 1, minus 1, minus 1, and minus 1, minus 1, 1. So you have to find the right option. So let us start with its solution. This is going to be easier than the 10th one, okay. So now again the unit of velocity is meter per second, so you can write the dimensions of velocity as L1 m0 t minus 1. Now the formula for coefficient of viscosity can be written as eta is equals to F upon A into dV by dx, okay. So force will be kilogram meter per second square, area will be meter square, and this is velocity upon displacement, okay. So velocity is meter per second and displacement is meter, so only per second will remain there, so that is second raised to minus 1, and writing the dimensions like this and combining them will give you L minus 1, m1, and t minus 1, okay. So now you have got the dimensions of coefficient of viscosity, that is eta, as L minus 1, m1, and t minus 1, okay. And now we'll go towards the density. The unit of density will be kilogram meter cube, right? As you already know that density can be written as mass upon volume. So mass, and this is volume. And now the dimensions of density will become L minus 3, m1, and t0, okay. So the last thing that we have to find the unit or write the dimension of radius, which is meter. So the dimensions of radius will be what? L1, m0, and t0, okay. And now we have got the dimensions of velocity, dimensions of coefficient of viscosity, dimensions of density, and the dimensions of radius. So let us go to the substitution part. We already know that from the given value that critical velocity is eta raised to x, rho raised to y, and r raised to z. Now substituting their dimensions will give you this, okay. This is dimensions of critical velocity or velocity, this is dimensions of coefficient of viscosity, this is dimension of rho, that is density, and this is dimensions of the r, which is radius. Now solving them further will give you this term, okay. And now comparing them, you can write this minus x minus 3y plus z equals to 1, minus x minus 3y plus z equals to 1 from comparing L, x plus z equals to 0 from comparing M, and minus x is equals to minus 1, that is x is equals to 1 from comparing t. So this is our equation number 1, this will be our equation number 2, and this will be our equation number 3, okay. So now we already know that x plus z equals to 0, that is from equation number 2, okay. So from there you can write x equals to minus z, right, okay. And we already know that our value of x is 1, okay, which is from equation number 3. So we are substituting the value of x only, so you will get the value of z as -1, and I am giving this as equation number 4. I am giving this as equation number 4, and now substituting x is equals to 1, that is from 3, and z equals to -1 from 4. I'll get this as x will become 1 and z will become -1. So now solving it further will give you -3y is equals to 1 plus 2. Why? This is -1, this is also -1. So this -1 will give you -2, and this will go on the other side, will become +2. And now on solving again, so y will become as 3 upon this -3 will come into the denominator, okay, and now y will give you value as -1, which will be your equation number 5. So we have got the value of x, value of y, and value of z, right? So value of x, y, and z can be written from equation number 3, 4, and 5. So value of x is 1, value of y is -1, and value of z is -1, which is saying that our option C is right option. Okay, so our right option will be option C. Okay, so this is an end, and finally, if you like this, please like my video, share my video, and subscribe to my channel. Thank you.